Hi everyone, in today's lesson we're going to talk about applications of long division and how it could be helpful to answer some questions. So let's look at example number 1. It says use long division, or synthetic, to factor f of x completely if f of x is this and f of x has a factor of this. Well, some of you might be thinking, if I want to factor something completely, why can't I just use the factoring methods that we've learned before? So let's just try that. This function f of x is 4 terms, so we would attempt to factor by grouping. So out of the first 2 terms, a GCF is x squared, and we'd be left with 6x minus 19. And then a GCF of the second 2 would be 4, and we'd be left with 4x minus 1. Now some of you should be saying, well, these two binomials are not the same, so I can't continue to factor this by grouping. And honestly, that's the problem. That's why I have to use long division, because I cannot factor this alone. So they have to tell you one of the other factors so that you can find the rest. So let's go ahead and use synthetic division now. I could use regular division, but since this is in the form a number x minus 2, it's easier to use synthetic division. Remember, if x minus 2 is the factor, then 2 is the root. And we're going to put the coefficients, 6, negative 19, 16, and negative 4. Bring down the 6. Okay, now we're going to multiply. 6 times 2 is 12. And now we're going to add. Negative 19 plus 12 is negative 7. Now we're going to multiply. 2 times negative 7 is negative 14. And then we're going to add. We should get 2. Now we're going to multiply. 2 times 2, that gives us 4. And then we're going to add. And we get 0. So if x to the third was my power in the problem, then the power is 1 less in the answer. So it would be 6x squared minus 7x plus 2 with a remainder of 0. And a remainder of 0 must mean that it's a factor. So as of right now, if we want to write out the factors, here's the original problem. We have 6x to the third minus 19x squared plus 16x minus 4. And we know one of the factors is x minus 2. And we just found out that the other factor is 6x squared minus 7x plus 2. And now what we're just going to do is continue to factor. It looks like we have a trinomial here that we could try to factor a little bit more. We can leave the x minus 2. This trinomial, unfortunately, has a leading coefficient greater than 1. It has this 6 here, so we're going to have to use something called guess and test. So I'm going to try, I don't know, put a 3x here and a 2x here, and maybe I will try a 1 and a 2 and see what happens. This would multiply to 4x, and this would multiply to 3x. Is there any way I can get a 4x and a 3x to add to this negative 7? And the answer is yes, if they're both negative. So negative and negative go in there, and these would be my final factors. Okay, let's see example number 2. Same kind of problem, and they want to know how to factor this thing completely. I'm going to show you how you could use, instead of synthetic division, you could have used regular long division. So we'll put the factor out here, x plus 3, and we'll put the 2x to the third plus 11x squared plus 18x plus 9 in here. And let's use some long division. So what do I need to multiply x by to get 2x to the third? You should be saying 2x squared. And now we're going to multiply. 2x squared times x is 2x to the third. 2x squared times 3 is 6x squared. And we'll subtract. We get 5x squared plus 18x. And how do I multiply to get x to 5x squared? We're going to multiply it by 5x. So 5x times x is 5x squared. 5x times 3 is 15x. And we'll subtract. These cancel. 18 minus 15 is 3x. And bring down the 9. How do I multiply to get x to 3x? We're going to multiply by 3. So 3 times x is 3x, and 3 times 3 is 9, and when we subtract them, we get 0. Perfect. So that means 2x squared plus 5x plus 3 times x plus 3 equals this. So if we wanted to write out the factors, we have 2x to the third plus 11x squared plus 18x plus 9. One of the factors is x plus 3. The other factor is 2x squared plus 5x plus 3. And again, we're going to have to factor this piece a little bit more. We keep the x plus 3. So again, we have a trinomial, and the factors of 2x squared will go here, so a 2x and an x, and we need to somehow have the multiples of 3, or factors of 3, add to 5. So multiples and add. So let's see what we got here. I'm going to probably put a 3 here and a 1 here, and let's see if that works. 3 times x is 3x. 2x times 1 is 2x. If I make them both positive, they add to 5x. So plus and plus. And these 3 are my factors. Alright, let's move on to the next page. Now, there's something called the remainder theorem, and what it does, it allows us to evaluate a function. So see how it says evaluate the function at x equals 4 without using the calculator. Normally, what you would have done is you would have said, okay, if I want to evaluate this thing, you would say, I'm going to plug in 4 for x. So let's do that. You all have calculators. So take a minute, put this whole thing, just the way you see it, into the calculator and get me a number. Pause the video until you've done so. But I think your answer should be 30. So I'm going to prove to you that we can get this number 30 without actually plugging this number into the calculator. And we're going to use something called the remainder theorem. So basically what it says is that if you divide any polynomial function, which we'll call p of x, by some factor, which we'll call x minus a, it will equal something with a remainder. So basically, when you divide this, you're going to get a quotient, q of x, plus some remainder, which we'll call r of x. So after you divide them, you're going to get a quotient plus a remainder. And the remainder theorem says that this remainder, r of x, is equal to the function p evaluated at a, at whatever this factor was. So if I evaluate it, I should get the remainder. So let's see. I would like to use long division to find the remainder instead. So if x equals 4 is the thing that I want to find, I have to put into the synthetic division the 4, and then I'm going to put here the coefficients. Notice how they're missing a 2 because it goes a 3, 2, 1, nothing. So we need to do 1 for the x to the third, 0 for the x squared, -7 for the x, and -6. So bring down the 1, multiply the 4 and the 1, and add. Multiply the 4 and the 4, and add. Multiply the 4 and the 9, and add. Look at that, 30. So what this tells me is that f of 4 is equal to 30, or corresponding on a graph, when x equals 4, y equals 30. So this is a polynomial function, so it should look something along the lines of this. It may not go exactly through the origin, but it's a polynomial cubic function. So this point here would be 4, 30. Alright, let's see if we could do the second example. So again, without a calculator, let's see if we can evaluate this whole thing when x is -2. Now we can use synthetic division again and put -2 here. It's much easier than using long division. And we'll put all of the coefficients. Do I have all the powers? I have a 4, a 3, a 2, a 1, and a number. Perfect. So 1, 10, 21, 6, and -8. So bring down the 1, multiply the -2 and the 1, and add. Multiply negative 8 and negative, 8 and negative 2 is negative 16, and add, multiply, negative 2 and 5, and you'll get negative 10, and then add, and then multiply, and then add. So 0 should be telling you something. If you get 0, what does that mean? So that tells me that f of negative 2 is equal to 0. So this corresponds to a point, negative 2, 0. Now this is next to the fourth, so what does that look like? Again, I'm just doing a quick sketch. I don't know exactly where the roots are, but I'm sure it goes like some up and I don't know, it goes down somewhere, who knows. But what that tells you is negative 2, 0, we'll say it's this point, is a point on the graph. Therefore, this is a root. Alright, that's pretty cool. Alright, if you have any questions, please jot them down and we'll go over them in class tomorrow.